Today we're going to be looking at solving systems of equations by graphing. To introduce us to this is something I'm not quite nerdy enough to have, but would love to have the space in my house for. These are sets of tangram shelves, so they have all 7 pieces of the tangram figures, but they're separated so you can arrange them in any way that you want. And like I said, not quite nerdy enough to have them, but I think they're awesome nonetheless. First of all, let's talk about what solutions to systems of equations look like. A system of equation is just 2 equations. So here I have x plus 2y equals 6, and we have 3x plus y equals 11. A solution to a system of equation is an ordered pair that satisfies both equations. So that means when I put 4 in for x and 1 in for y in both equations, it should work out. So let's try. For the first equation, that's 4 plus 2 times 1. We want to know, does that in fact equal 6? So let's see. 2 times 1 is 2, so that's 4 plus 2, which does in fact equal 6. So the ordered pair works for the first equation. Let's try the second. 3 times 4 plus 1, does that in fact equal 11? Well, 3 times 4 is 12, and 12 plus 1 is not going to be equal to 11. 12 plus 1 is going to be 13, so that is not a solution to both ordered pairs. If it was a solution, then it would work out for both equations just like it did in the first one. When we talk about solving a systems of equations problem by graphing, we are going to be graphing some equations. How those equations appear on our graphs are going to tell us how many solutions they have. For example, looking at the red and blue lines, this first graph, the red and the blue line intersect at one point, so there will be one solution for this first problem. This graph, the lines overlap each other. So because they overlap each other, there are going to be infinitely many solutions. For the final graph, there's no point of intersection for these two lines because they're parallel. So for that, there are no solutions. So depending on how your graph appears when you graph your two equations, you will either have one solution, infinitely many solutions, or no solutions. Let's take a look at this first problem. We've got y equals 2x plus 2 and y equals 4x plus 6. We're going to start out by graphing these equations. So y equals 2x plus 2. My y-intercept is at the ordered pair 0, 2, so I'm going to graph that. And then I'm going to go up 2 over 1 for my slope. And I'm going to do this several times to make sure that I get a very accurate graph. I can even go down 2 to the left 1 several times to get, again, a nice, even, pretty looking graph. And the graph itself is going to look oops, I messed up on one of my points, or two of my points. The graph itself is going to look something like this for the first equation. For the second equation, we've got y equals 4x plus 6. So I'm going to start at the ordered pair 0, 6 and graph up 4, 1, 2, 3, 4 over 1. Again, I'm going to do a couple points. I'm going to go down 4, so down 1, 2, 3, 4, left 1, down 1, 2, 3, 4, left 1, 1, 2, 3, 4, left 1. So once I get my equations graphed, you should be able to see that I have one spot where these 2 points or 2 graphs overlap, and that's the ordered pair -2, -2. Let's test that point to make sure it does work in both equations. So if I put it in the first equation, does -2 in fact equal 2 times -2 plus 2? Let's see. 2 times -2 is -4. -4 plus 2 is -2, so it works for the first equation. Let's try the second. Does -2 equal 4 times -2 plus 6? 4 times -2 is -8. -8 plus 6 is -2. So that ordered pair is in fact a solution. For this problem, we're going to do the exact same thing. Our equations aren't in slope-intercept form, so you have one of 2 options. You can put them in slope-intercept form. Well, actually you have one of 3 options. You can write them in slope-intercept form. You can solve using your intercepts. Remember, that's where you take turns, letting x and y equal 0. Or you can create a t-chart, substitute in values for x, and find y. All 3 methods work, and all 3 are fairly easy. To me, the easiest is to go ahead and set them up in slope-intercept form, so that's what I'm going to do. For the first equation, to get y by itself, I need to add x to each side. Five and x are not like terms, so I'm not going to combine them. So my first equation is y equals x plus 5. My second equation, I need to get y by itself as well, so I'm going to subtract the 2x from each side. 2x and 8 are not like terms, so I cannot combine those either. So my second equation is going to be y equals -2x plus 8. Notice that even though I subtracted the 2x, since the 8 was positive to begin with, I used an addition sign between the values. Graphing these, the first equation, y equals x plus 5, starting at the ordered pairs 0, 5. And I have a slope of 1, so that's up 1 over 1. Up 1 over 1. Up 1 over 1. My second equation, y equals -2x plus 8. So I'm going to start at the ordered pair 0, 8. Go down 2 over 1. Down 2 over 1. Down 2 over 1. Here we're going to be able to see fairly easily which ordered pair overlaps. If it's not as easy to see, you may have to extend your lines out, and there's no harm in drawing them extra long just to make sure that you do in fact have that intersection clearly labeled. Our ordered pair appears to be the ordered pair 1, 6. Let's test to make sure. For the first equation, and I'm going to go back up here to the original equations, not the ones that I used, just to make sure I didn't make some brain fart error. So -1 plus 6, well, that is 5, so that works. For the second problem, 2 times 1 is 2, plus 6, 2 plus 6 is 8, so it works for both equations. So that is the solution. Try these 3 homework problems. The first problem is already set up in slope-intercept form. The next 2 you will need to use one of your three methods to graph these equations. Graph the equations, find the number of solutions, and if there's only one, tell what that solution is. Have a great evening.